okay? These are the ones you would have a calculator on because you have to divide, okay? These are your SOAR questions. So 8, your S is 6.663, and it put your radians was 0.34 pi radians. So that's in the first quadrant. 9, theta, 4.689. This is a case where you have to divide by pi if you want to know where that is. It's 1.493 pi. That puts it in the third quadrant. 10, your R is 6.485, and your angle was given to you in radians, not in terms of pi. So that 4.58 had to get divided by pi. 1.458 is what you got. Again, puts it back in the third quadrant. And then 11, your arc length 26.196. Again, question gave you the angle, but not in not in terms of pi. You had to divide by pi, and it would have been 1.767 pi, which is in the fourth quadrant. Any questions on those? So you're going to get given two of the 3 pieces of information. Ask for the third. That part obviously shouldn't be too difficult. You're just dividing or multiplying depending on what it is. Just be careful. And then you'll have to answer where it's located, where theta is. All right, these were your other ones where you get given the radius, and it's asking for sine, cosine, tangent. I don't want to read every single answer, so you let me know if you have a question. And again, I just posted these. I feel like these are pretty straightforward. The SOAR questions are pretty straightforward. These are pretty straightforward. So there are some that are just like that easy. Just be careful. It would stink to make a mistake on something like this. Let's say it's on the non-calculator portion, for example. So like number 3, if it was on the non-calculator portion, it would just be left as negative 1.495 over 4. So you could see it in both ways. With the calculator, where it would be the highlighted answer, you'd actually have to divide. Without the calculator, where you leave it as a decimal.
Is the test multiple choice for your response?
It's both. Yeah. I would say it's mostly multiple choice, but there's a couple open-ended, and then the multi-part one, like increasing, decreasing, concave up, concave down, just like we've been practicing. All right, then we got to our trying to find the coordinate points. If you're given the angle and the radius, these are on the non-calculator portion. These are kept exact. This is open-ended, so it's not multiple choice. Be careful with your signs, I would say here. And obviously you need to know your unit circle angles. If you wanted to, when you get it, right on the corner, you're over 6, you're over 4, you're over 3, and add on the tangents, because that's going to help you later. Like I would maybe recommend that. And then you're one less than double. Yeah.
Can you do 5?
All right, so 5 says the theta is pi over 2 and the r is 9. So you're still doing the radius times the cosine of theta, and then the radius times the sine of theta. Our theta is pi over 2. And at pi over 2, which is at the top, your coordinate point is 0, 1. So the cosine there is the x, which would be 0, and the sine is the y, which would be 1. So 0, 9. If you were to actually draw this, if you think about it, pi over 2 is at the top, and you would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and that coordinate point would be 0, 9. You could do that with any of the quadrant angles. You could literally plot it and double check your work.
Okay.
Yeah. And then we got into the reverse ones where I gave you the coordinate point and you have to give theta and the radius. This is also open-ended because it's got the 2 parts, and it will be kept exact. Questions on any of those? Okay, then came your, higher level questions where you get the scenario of either sine or cosine, and you're comparing it to a spot on your unit circle within the range that's given. So the 2 most important pieces of information, is it sine or is it cosine? And where's the angle that they want you to focus on? What's it between? So theta and what, or what and theta, is it where it's between? And then if you're comparing your x's or your y's. Yeah.
Can you explain that more?
Yep. So it's talking about the sine, which means the y, right? And it wants, theta's given to you. This is your theta terminal point. It wants you to describe between theta and 2 pi. So you're in here. So we're comparing these values of y to the blue value of y. So y is top to bottom, right? This time all the alphas are first. So we're talking about the green angle is the alpha. So the alpha, what's true about all those y's, it's going up. So all the y's would be bigger than the initial coordinate point that's here. Does that make sense? Okay. Okay, then like 3 through 8 on this section is literally memorizing what your sine and cosine curves look like. I would say you're probably drawing at least one of those at some point, like all the way out, so that you can answer questions based on it. Remember your 5 key points. Remember the shape of it. Rolina.
On number one, so you're not focusing on the theta angle?
Well, you're comparing the values of either sine or cosine on the angle that's in the range they gave you to the value of either sine or cosine on the terminal point of theta. Yep. Because think about every time, if I said, well, pi, like 5 pi over 6, we use the terminal point. Even though it's here, we use the terminal point to talk about sine and cosine. So it's always where it ends. Does that make sense? Okay.
Are there gonna be questions on there, defining the periods, kind of?
Yeah.
Like, when, in the interval of 17 and 30, what is the behavior?
Yep. Yeah, was that the other way at the end?
Oh.
Yeah, it's all the way at the end. Yeah.
What's the difference between D and C again?
D and C, the here and here?
Yeah.
So this means they are literally equal to each other. They would literally have to be the same angle, or it'd have to be like an angle over here where the sine would be the same. It would just be one singular point, which is very unusual, but that's an option, okay? The other option is that if it was, let's say we went the other way. Let's say it gave you this angle, okay, or that range as your alpha. It would have said from pi is less than alpha is the variable they use, which is less than theta. Let's say it did that. Now you're talking about that red arc, right? When you compare the y's on that red arc, or the vertical displacement, to the y on your terminal point, those y's dip down below and then come back up again. So that's a D scenario. Sometimes it's bigger and sometimes it's smaller. Like if I put a dot here, that dot is lower than my red dot, right? It's going down. But if I put a dot here, that dot is higher than my red dot, so it's going up. Does that make sense? Okay. Yeah.
And then for number 2, when it's theta.
Now it's between theta and pi, so it's this arc, right? It's this angle here.
No, but that, the way you circle it in red, it just means it goes to half the circle. Right?
Well, it's going from where theta ends to pi. Yep. We're good on these? Yeah.
Wait, for number 2, why is A less than?
Because you're talking about the x values, right? Because we're talking about cosine. So here, well, let me highlight in a color you can see. That x is further to the right than all these x's, right? All of those x's are left of it. So don't worry about that shape this way. Just move left to right because you're doing cosine. So all of those x values are less than my original blue point. So the alpha would be less than the theta. It would be both.
Yeah, it would be D.
Yep. All right, last page was your period, your amplitude, and then the increasing. Oh, I opened this up and I lost my answer. Okay, so that we can do this together. The period, you can either go from here to here, okay? Or you could go maximum to maximum, however you want to figure that out. This would be 7, 8, so the period is 8 here. If you start at the 0, then you can use multiples of that period in order to create your next interval. That's the perk of starting at the 0. So if it's saying, is it increasing, decreasing from 45 to 51, what's the multiple of 8 that's before 45? 40. This would be 40, 41, 42, 43, 44, 45, 46, 47, 48. And it stops, and I need to go to 51. So I'm going to keep going. This would be 49, this would be 50, this would be 51. So for me, it's easier to see it in a fluid shape, but if I wanted to duplicate it and put 48 back at the beginning, then it's a little bit harder to see. So because it says 45 to 51, I'm looking on that curve there. So is my function increasing, decreasing, or both? It's doing both. Part of it's coming up and part of it's coming back down. The next part says from 12 to 18. So before the 12,
8.
good. Let me erase this. This is 8, 9, 10, 11, 12. So I want to go from 8 to 12. No, sorry, from 12 to 18. I should have kept going. 12, 13, 14, 15, 16, 17, 18. So I'm going from 12 to 18. I'm going from this spot to this spot, okay? And on that section, your graph is both concave up, because it's concave up here, and it's concave down, because it's concave down there. So this is both. And then C, is there a relative max, min, or neither at point 34? So the multiple of 8 that comes before 34 would be?
24.
Go one more.
32.
32, good. So 32, 33, 34. And this point here would be a maximum. A relative maximum. It's not global because it happens again, but it would be a relative maximum. Questions? So it could ask you the period. If it's on the x-axis, it could ask you the amplitude. It could ask you concave up, concave down, relative, max, min, increasing, decreasing, both. That's gonna be like your multi-part question. We good? Yes? Okay, I have a class. All right, so this was the first one, right? So all the cosines are there. Obviously, I'm not going to make you fill out a chart, but you got to know all those cosines in order to apply it later when it starts asking for the coordinate points. The intervals on which the values are increasing, I would now draw the wave. Okay, I think it's easier. You can see it from the chart, like pay attention to your cosine values if they're getting bigger. So like from 0 to a half to square root 3 to 1, on this interval, they're getting bigger. So I could use it there. Well, all the way from here because it's negative root 3. But I think it's easier to see it from the wave. So it would be from pi to 2 pi, and you could either write it in interval notation or you could write it in inequality, where they're decreasing from 0 to pi, and then again, could be interval notation or it could be inequality statements. Now this, because of the wording, it says state the maximum points. I actually think the preferred would be the coordinate point. If it said state the maximum value, you're looking at 1. If it said when does the max occur, now you're looking at the angle in which it occurs, or where does it occur. Those are the x values. So just watch the wording on it, okay? And then min, pi, and -1. Again, the minimum value would be -1, but the coordinate point is that pi, -1. Yeah.
I have a question. Is it okay if we did like pi, comma, 3 pi over 2, and then union, and then up to
Where?
3 pi? No, for me, like I didn't write pi, comma, 2 pi. I wrote it out fully.
Well, the problem with that is that you're using parentheses, so you imply it stops, and it doesn't. Does that make sense? The parentheses say skip that. So you're saying, does that make sense? It needs to be one fluid. He said, can you write this in 2 terms? Can I write that as pi to 3 pi over 2? And then union 3 pi over 2 to 2 pi. But you're implying that the graph would stop moving at 3 pi over 2, and it doesn't. So you want it to be one fluid thing. Does that make sense? Okay. Then the sine curve, okay, this one is increasing from 0 to pi over 2, and then from 3 pi over 2 to 2 pi. It's decreasing from pi over 2 to 3 pi over 2. The maximum point would be pi over 2 and 1, and the minimum point would be 3 pi over 2 and -1. Good on that one? Okay. Then your coordinate points, so it should be -4 and then 4 comma root 3. -4 comma 4 root 3, and then -3 root 3 comma -3. Make sure the negative angle, for me, I go to where it's positive and I just flip it over the x-axis. You could also move in the counterclockwise location. In the clockwise. Okay, so this one I kind of wanted to go over live because there are more than one way to draw this, okay? The The foundation of it is that you have to identify an amplitude and you have to identify a period, okay? The amplitude comes from your maximum, your minimum. The period comes from how long it takes to complete one cycle. So when you read this, it says it takes 10 seconds to travel from the top of one wave to the top of the next wave. That is one cycle. So if it said to do this twice, then I'd have to take that 10 and divide it by 2. So think about the wording that could be there. So that tells me that the period is 10. That means I start and stop at 10, okay? Then it says that the range of the swells are 4 feet from the top of the swell to the bottom of the swell. It doesn't, there's no water level on this graph. So how you choose to get from bottom to top is up to you. I could literally say, oh, this is the bottom, and I'm gonna go up to 4, and then I'm gonna come back down to 0, and then I'm gonna go to negative, not 4, sorry, that would make it double. I would go up to, no, I could go to 4, and then back down to 0, and then go back up and make this a cosine curve. I could make it like this. I could make it like that, and I could make it a cosine curve. This would still be a bottom of 1, a top, well, I went too high there. A top at 4. This is still a swell of 4. So it could look like that, okay? I could say that the height of my wave is actually at the 0, and I could go down to 4 and then back up to 10. That's still right, because that's still a swell of 4. If you want your middle line, so again, it's called a midline. We're going to get more into it as we move into the next sections, but if you want your middle line to be that center line, then you can only go up 2, and then down, and then back down 2, and then up again. So it would look like this if I made it a sine curve. I don't expect it to be perfect yet, but when we get into, like, when we move forward, the cross, like how you draw these curves is start to finish is your period, and then halfway between them is where it would cross through. So 5 is where it crosses through. A quarter of the way in is where it hits its max. 3/4 of the way in is where it hits its min. Okay, you don't need to know that for tomorrow's test. You would need to be able to look at a multiple choice and say, okay, that one matches this scenario. Okay, but eventually you will get here, and then you'd have to label those points and all that good stuff and talk about the midline. But we're not there yet. So this one would have an amplitude of 2 and a period of 10. Questions?
So the amplitude wouldn't be.
We'll say something like sea level goes from 10 feet to 2 feet. That's your max, that's your min. You'd have to split the difference to get the amplitude, but we're not there yet.
So since 4 went from top to bottom,
Correct.
it's just in the middle.
So
Correct.
what do we
Okay,
have
okay,
is,
then you should have just.
You'd have to know if you saw a graph and you saw the max and the min, you'd have to be able to identify that the amplitude's half that
Wait,
distance.
then what's the max?
Okay. I identified all the maximum points. If you had given coordinate point, if it had asked for what they were, you would give it in coordinate points. Okay. Actually, it would have said just in this case, it said max and min values. I would have just given 2 as the max and the min -2, because it said if it had said what is the maximum value. Then your intervals of concave up and concave down. Concave up are all the green, all the U's. Concave down are all the yellow, all the N's. And then the points of inflection are where those two change. So on this case, it was everywhere on the x-axis.
Would we have to show all of them?
No, it might be ask you part of it. It could ask you in multiple points. The point of inflection is the only thing you won't see tomorrow. You'll see max, you'll see min, you'll see concave up, concave down.
No, I mean what we have to show, if you give us something like that.
If it said the whole thing, then it's the whole thing.
Okay.
Yep. Yeah.
Can you go back for 2 seconds?
And then you